Welcome, everybody. Good morning, and welcome to today's Getting Started with Kubernetes and Rancher online training. We have people joining the line. We are just starting right on time, it looks like. Just going to wait a moment for more people to join. And while I do, I will just mention that this whole recording, this session will be recorded, and everybody, on the training or who registered will get the recording and the slides and the Q&A and everything you need. So yeah, why don't we go ahead and get started? Just as background and sort of context for today's training, we have 90 minutes essentially to give you all a pretty solid technical introduction to Kubernetes using Rancher. That is really our main goal. We do have slides to get through, but this is very much meant to be interactive and demo oriented. So we're just going to demo. There is a chat. Please put your questions in the chat, when you think of them, and we try to get to every single question. It's really, again, meant to be interactive. These technologies of Kubernetes and Rancher are open source and very much community driven and contribution driven. So your feedback, your interest really helps shape this training and shapes the technology. So just as a way of introduction, my name is Matthew. I'm kind of like the community advocate at Rancher, and the technician engineer on the line is Prachi. Super glad to have her today. She's been writing a string of awesome articles moving from cattle to Kubernetes and Rancher 1.x to 2.0. So super happy to have you here, Prachi. Thanks for taking the time.
Hi, everyone.
Hey. All right. So just a couple more sort of getting started pieces. The context for this training, we kind of come in here hoping that you have some understanding of Docker containers, basic understanding. And if you don't, it's okay. I think you'll still get a lot from the training. I know a lot of other people have. Please do ask questions about Docker if you have them that's pertinent to what we're talking about. And this is an intro training, so we try to keep within the scope of an intro level. And if you don't understand something, we can't answer something, we might refer you to an outside resource like our Slack channel or forums or something like that, and or a lot of articles too. So if you want to follow along with the demo with your own Rancher instance going, you can get one deployed for free pretty fast, a couple minutes, by following the deploy button in the top right hand corner of rancher.com, and that'll take you to the quick start guide, and you should be able to get up and running really soon. Part of the demo will be kind of showing you just in brief like an install, and so if you do have trouble, you'll be able to see how it's done. Other resources before we get started, just our Slack channel and our forums are really popular. There are questions asked in our Slack, every day throughout the day, and we do have engineers on there answering questions and a lot of expert users who have been working with Kubernetes or Rancher for years and are happy to participate. So if we can't answer something, or we run out of time or whatever the case may be, please plug in to those community focused resources and get the help you need. So with all that out of the way, we can finally get into the meat of the material. So I'm going to pass this over to Prachi. Are you ready, Prachi, to take the
Yes.
Helm presentation?
Yes.
Okay,
Yep.
cool. Let me share presentation, give it to you.
Okay. Sharing my screen.
Yep, I see it. You're good.
I'll start my slides. Okay. Do you see it good?
Yes.
Okay. Welcome, everybody. I'm Prachi Damle, software engineer here at Rancher Labs. I have worked for last few years on Rancher 1.6 platform, and recently have been working on Rancher 2.0 version as well, which is based on Kubernetes. So we will be doing a couple of slides first today, then we will jump on to the demo, as Matthew said, and go over a couple of cool features of Rancher 2.0. So Kubernetes momentum. First of all, I want to give you a bit of information around why Rancher has shifted to use Kubernetes as its base orchestration platform. So before Kubernetes, we had Rancher 1.0 that used our own orchestration platform called Cattle for deploying Docker containers. But with 2.0, we realized that the Kubernetes ecosystem was just getting bigger and bigger. Also, it supported good design patterns, robust design patterns, helped scalability, efficient resource usage, and it is also backed by a lot of software companies. Like GitHub, many companies have publicized their use of K8s. It is also backed by a solid developer community, user community, and many companies, many IT vendors have also recently added their Kubernetes offerings. So on this slide here, you can see the contribution by various companies from various sectors. And it's not just Google that is contributing to it. It's a lot of different companies who are interested in making Kubernetes better, making it grow. There are also many companies are interested in starting their staging or production environments on Kubernetes. So out of these companies, you can see there are leading infrastructure software providers like VMware, Red Hat. They are shipping Kubernetes distros. There are also infrastructure cloud providers like Amazon is there, Google is there, also Microsoft Azure. They have all launched managed Kubernetes services. Thus, Kubernetes everywhere is really becoming the reality of the cloud and infrastructure domain. It is becoming a platform of choice for many enterprise and open source users because of its rich feature set. But there are a lot of operational challenges in adopting Kubernetes. There are so many ways to deploy various resources on Kubernetes, and how to deploy all these resources consistently across all the available variety of infrastructure platforms is a challenge. Kubernetes is huge, it's feature rich, but it is complex. And there are so many ways to do things. All enterprises and users are starting to adopt Kubernetes, but they are faced with questions like how do I deploy the resources on all the available infrastructures? How do I manage multiple clusters that are launched with Kubernetes? And these clusters may be launched on different cloud services, but how can I integrate them into one central portal and manage them from there? Or if I'm an enterprise customer and I already have an existing authentication system for my enterprise, how can I integrate with that authentication system and provide access control and authentication features for my users? For example, then there might be Active Directory or SAML systems that are already in place. And if you want to roll out your systems newly onto Kubernetes, how can this existing system be integrated? Also, how can the resources that I have be managed efficiently? And how to provide features like, say, multi-tenancy, provide alerting, monitoring of workloads. So there are a lot of challenges that are presented to a new Kubernetes user. So one of the goals of Rancher when we switched to Kubernetes is solely focused on making all of these easier for the users. Additional challenge in adopting Kubernetes is the fast-paced development of this project. Kubernetes development is moving very, very fast. There are almost more than 50K commits within a year, and it's top 5 of all the GitHub projects. There are a lot of pull requests and issue comments than any other project on GitHub. So because of this rapid pace, it is changing so fast that it becomes hard to keep up with all the updates that are coming in and upstream releases that are coming in. And another challenge on top of this is there is no long-term support version available with Kubernetes. Because Kubernetes releases so frequently, is a minor release every 3 months. And even though they are doing minor releases and they follow SIMWAR, they can break the major releases. For example, just if you go from 1.8 to 1.9, it doesn't mean they have not added any or deleted or changed any API. So keeping up with these constant updates is a bit painful. It is a good idea to have some help, and which is what Rancher can do to you. Now, further, there are also, even if you adopt Kubernetes, there are also usability challenges. So the instructions to deploy resources and use Kubernetes in the correct way are not clear. Users can't really leverage their prior Docker knowledge to write the Kubernetes specifications and get things deployed quickly. Thus, anyone coming from the Docker side or the Rancher 1.6 side has a steeper learning curve in adopting Kubernetes. There is a lot of new stuff to learn before you can start using this platform. For example, if you are from the standard Docker or Cattle side, you must be familiar with Docker Compose and the ease of use it provides. But Kubernetes does not use this standard Docker Compose syntax. It has defined its own YAML specifications that we need to learn before we can start using this platform. That is where Rancher 2.0 is useful. With Rancher 2.0, you can use all this orchestration power and the features in an easier way. So Rancher and Kubernetes makes it better together. So what do we provide as part of Rancher 2.0? It is an open source container manager platform to run Kubernetes in production. The key features are, as always, there is a very intuitive and useful, easy to use user interface. It helps infrastructure management across multiple clouds and clusters. So Rancher becomes a single point to manage all your different clusters together using a central portal. Rancher 2.0 also facilitates automated deployments of the latest Kubernetes releases. So you don't have yourself to keep up with the upstream releases. Rancher will do that for you. Along with all these features, the key features of container orchestration like workload deployment, RBAC policies, and some extra features like project management, providing multi-tenancy, are also available with Rancher 2.0 platform. On top of all this, there is a 24/7 enterprise grade support that we offer. Now the product Rancher 2.0 itself is not different when it comes to enterprise versus open source. The product is same, but with if you want the support, we always offer the 24/7 enterprise support. The next slide here shows the Rancher 2.0 container management platform stack. Now, as you can see, here on the top is the application management layer, which consists of the user interface, the cool UI that Rancher 2.0 provides. Then also there's an application catalog, which is already available Helm charts that you can just click and launch various applications from. There are various tools available for monitoring, loggings, and CI/CD. All this application management rests on the management layer, which is a unified Kubernetes management layer, which facilitates the provisioning of workloads, upgrades and rollbacks, provides various authentication policies and security policies. Also, on top of that, Rancher 2.0 offers role-based access control model. Now, all of these features, while implementing them, Rancher makes use of the native Kubernetes platform. So All of this is resting on the native Kubernetes platform. Then Rancher 2.0 will pretty much run everywhere with anything you want. It comes with connectors and drivers to integrate with Kubernetes providers like the EKS, Amazon Web Services EKS, Google Cloud Platform GKE, or Microsoft Azure AKS. It can also work with an array of infrastructure providers. So you can launch nodes from various infrastructure providers like EC2, Azure, DigitalOcean, or you can launch Rancher as well as pull in nodes from your bare metal server. Now, this is a quick overview of how the Rancher 2.0 components are aligned. The box in the middle is the Rancher server, which runs in a container. It consists of various components like the Rancher API server, which is listening to all the Rancher UI requests, CLI requests, or any other client that is integrating with Rancher API. Then it has an auth proxy to handle authentication and that integrates with various authentication providers. And Rancher API server uses etcd, which is the same as the Kubernetes etcd for its database. So this is a difference from the Rancher 1.6 platform, where 1.6 used the MySQL for DB. Now Rancher 2.0 is using etcd for its database. Rancher server can then talk to all your clusters. It can be a GKE cluster or it can be an RKE cluster. RKE is Rancher Kubernetes Engine. It's a Rancher specific Kubernetes installer for spinning up Kubernetes clusters very quickly. If you're looking to set up a cluster, then RKE is very handy to get started. After this, let's go on to some Kubernetes basics, and we'll briefly go over all these concepts. These are few of the resources that are offered by Kubernetes, and going over them will help us to understand the further slides and demo. So Kubernetes, the basic resources are pods, deployments, then what is a Kubernetes service, what are config maps, and what are ingresses. We will limit this list to this, but you can always go to Rancher docs or Kubernetes docs to figure out definitions of other resources that you come across. Let's start with pods. Now, pod is the smallest unit that can be deployed in Kubernetes. Pod can consist of one or more containers that are always run together. So they are scheduled together and they can talk to each other. So each pod is given a unique IP address. The containers within the pod can speak to each other via localhost itself. So if you want to compare this to the Docker world, the smallest unit in Docker is the container. But when it comes to Kubernetes, one or more containers together in a group is called a pod, and pod becomes the smallest unit of deployment. So that's why pods are a little confusing when compared to the container world. Don't worry too much if it sounds confusing, because pods typically usually contain only a single container. So try to think as pods, as containers for the remainder of the training. For example, here we are showing a pod which consists of two containers. One is the Nginx and there's a Redis container. But they are always scheduled together and they can talk with each other over the localhost port. Now, to get more information in deep about these concepts, I just want to refer quickly to this very good book. It talks about many different design patterns that you see in Kubernetes. If you are interested and if you want a basic knowledge and vocabulary of various terminologies, we do recommend you get this book. Moving on to the Kubernetes concepts. Next is the replication controller and replica set. Using replication controller, you can specify how many pods, also known as replicas, are desired to be always running for your application. And the replication controller will ensure that those many replicas are always available. So Kubernetes orchestration engine, once you provide it a replication controller or a replica set, which is just next generation of the replication controller, the Kubernetes engine will make sure that the said replicas number of pods are always available. So both of these are going to define the desired state of a group of pods. They are then going to drive that state to the controller manager. So that means if you are requesting 10 pods in your replica set and you only have 2 running suddenly, controller is going to kick in. It is going to try and get the 10 pods running for you again. All of this, of course, depends on the resource availability and many other constraints. But it's going to try its best to give you those 10 pods if you have requested them in your replica set. Quick example of how a replica set is going to work. Say we are running a replica set and we have requested here 12 pods to be always present for my application. So these 3 boxes represent our nodes or servers, and we have the 12 pods which are currently running on these nodes. So let's say something happens and one of the node goes down. Now I only have 8 pods remaining. So what the replication control is going to do is it's going to check if I have room to spin up those 4 missing pods. So currently we are, say, lucky enough to have enough capacity on our remaining nodes, and Kubernetes will reconcile, bring it to the desired happy state of 12 pods. So this is pretty powerful feature of Kubernetes. Deployments. Deployments is just a level of abstraction above replica sets. They will control a replica set for you. They will create and update the replica sets. So if you create a deployment, it's going to create a replica set in turn, and replica set has the pod specification. So it will in turn create the pods. One of the advantages of deployment over a replica set is it does give you the feature of rolling updates and scaling your deployments. So as an example, we will take a look at how the upgrade works. So in this example, again, we are going to consider these 4 pods running on one of our nodes. And suppose this application pod is running its version 1, V1. Let's say we want to do a rolling upgrade with a batch size 2 whenever a version 2 is available. So Kubernetes will spin up the 2 new pods which are running V2. And there are 4 of V1 still running. We can do some testing in the background and determine that these V2 pods are good enough internally. And then we can do a 50% traffic split at this point, and the V2 pods will replace 2 of the V1 pods. Now everything seems good, so we decide to run V2 completely, and we can proceed with the next batch of upgrade and replace the remaining 2 V1 pods with 2 new pods running V2. So at any given point of time, there was no downtime while upgrading your service because of this rolling upgrade. If something goes wrong, there is always the rollback feature available with the deployments. Next concept to go over are services. Services define a DNS entry that can be used to refer to a group of pods. Now, pods in Kubernetes are ephemeral. So if you are using pod IPs to communicate from your external clients, then that is not a good idea, because pods can at any given time get redeployed onto some different hosts if the conditions on which the host on which they are running suddenly goes down, because of which the pod IPs change, and your external client, if it's using those IPs, will face errors and will require a change eventually. So that's why we need something, one abstraction layer on top of pods, which provides a consistent endpoint for the group of pods, which will not change even if the pods get rescheduled. So here comes the service. Service is a DNS entry, but that doesn't mean it's always externally available. Sometimes services are seen as external access given to pods, but it really depends on what type of service you have created for the group of pods. There are different types of services in Kubernetes. There's node port, cluster IP, and load balancer. So cluster IP service gives your service an internal IP address, which is reachable from anywhere within the cluster. This is not reachable from outside the cluster. Node port is going to give you a port, which should be available on any node where your pods are running. So this can be an external access depending on how your nodes are set up. Other type is load balancer service. Creating a load balancer service in Kubernetes for a group of pods configures the layer 4 load balancer if it is configured in your cluster. And this layer 4 load balancer will provide a public IP address to access your application. Here you can see a basic example. We have a deployment running, a group of pods running on 3 nodes. But as you can see, these pods can get rescheduled, redeployed on various other nodes. And hence you need a service on top of this, which gives you a service IP. And if it's an externally available, accessible IP, your client can reach it and keep on consistently using that IP, even if the pods get rescheduled in the background. Now, this service will load balance the traffic across the group of pods. Next Kubernetes concept we can go over is config maps. Config maps allow storing just arbitrary any key value pairs, any configuration data that you want to store and your pods want to access. So config maps can be exposed in the pods as environment variables or as local storage. So why not place your configuration values directly inside your pod specifications? Config maps basically help you decouple the storage of configuration from your pod spec. So your pod spec or your pod images need not change if your configuration parameters are going to change depending on the environment that you are going to launch the pods on. If we take a look at this, we have 3 different configurations for, say, QA, for dev, and for production. And all of these configurations for each of these environments are going to be different. But you can define a config map named dev config, and you can place your data as key value pairs in this config map. And then you can specify this config map in your pod specification. And even if the pods run on different environments, when you change the key value pairs in your config map, the behavior of the pods will change accordingly. Ingresses is an important concept in Kubernetes. Ingress is the popular way of directing outside external traffic to inside your cluster. Ingress defines how the traffic can be directed to your application service running on the Kubernetes. It is used to expose your services to the world. Ingress by itself is just a definition or a specification, and it usually has to be backed by an ingress controller in the Kubernetes platform, which will keep on listening and watching what ingresses are getting created. And this controller then goes and configures the load balancer, which is present in your Kubernetes platform. So there are many such ingress controllers which themselves are also load balancers. For example, Nginx, HA proxy, AWS ELB, and these components are available. Rancher 2.0 by default launches the Nginx ingress controller, which will keep on listening to the ingresses that you create via Rancher 2.0 and configure the Nginx LB accordingly. Here's an example for the ingresses. So we have the pods, which are running our Nginx and Redis containers. And we have the service IP, which is providing a public access endpoint on the group of these pods. You can also have an ingress controller, which is listening and configuring the Nginx LB and providing an external access to your application. Now, next, we are going to go to some Rancher 2.0 basics. Before going on, I would like to take a break and check if there are any questions. So, Matthew, are there any questions we have so far?
Yeah, thanks for pausing. Thanks for getting through that first part. So this first one is from Gallon, who says, he has tried to set up a rancher on his local machine. So he says, I quickly set up a rancher system on my local machine with one cluster. Now I've got 4 containers, 1 rancher server, and 3 rancher agents. But on the slide with the overview of the rancher system, everything seemed to be on one single container. What am I missing or not getting?
So Rancher server itself, which does all the orchestration for your applications, runs as a single container on the host that you have used. And when you are provisioned a cluster, and if there are any nodes that you are added to your cluster to provision it, each of these nodes will get a bunch of other containers that Rancher will launch so that it can access the cluster and talk to your cluster. So all the other containers that you're seeing are still part of the Rancher 2.0 system, and they are facilitating the communication between the Rancher API server, or the main container that we showed in the diagram, and your cluster nodes.
Awesome. Great. So there are a couple other questions, but I think once we actually get into the demo, it'll be a better time to take a moment and answer some of these, because they'll start to get answered as you go through the demo. So
all right.
Keep going. Yeah.
Sounds great. So moving on to Rancher 2.0 concepts. First thing that we will have to go over is how can you set up Rancher server itself. Then the concepts of clusters and how can you get multiple clusters set up in your Rancher server or through your Rancher UI. And we will also go over authentication model and security and RBAC policies that are available. We'll go over briefly over what are the storage features that Rancher 2.0 provides. Then what are projects and what are namespaces. And we'll also go over catalogs, which is Helm chart library that is also available in the Rancher 2.0 portal. Lastly, we'll quickly go over other ways of communicating with your cluster using Rancher CLI and the Kubernetes kubectl client. So with this, it's demo time. We are done with our slides and we can go over our demos. So I'll go on first to the Rancher 2.0 documentation. So you can go over the Rancher 2.0 documentation on the rancher.com site. And under Rancher 2.0, you can see that there is an overview, quick start guides to get you started fast. And there are other sections about various concepts. We will get started with the installation. Now, these are the node requirements. When you're configuring Rancher, you need your node or the host that you are going to install the Rancher server container on to be satisfying these requirements, these operating systems. This is the hardware that we recommend that you should have. When it comes to software requirements, we basically need a supported version of Docker installed on your node. These are the 3 supported versions as shown here. Now, why only these versions? Because Kubernetes upstream releases, they document these as the supported Docker versions. If you are using some unsupported version, it is still possible that Rancher will most likely run, but there might be some errors that suddenly can pop up. So it's good to always stick to the supported versions of Docker. Moving on to port requirements when you do Rancher installation. This following diagram depicts what are the basic port requirements for Rancher. These are the ports we are asking to be open, so Rancher can communicate to the different Kubernetes clusters that you set up. For example, port 22 we need to SSH to various boxes or nodes that you want to provision, and we can go to the node and install Docker and Kubernetes components on those nodes, and also Rancher components like Rancher agent containers. So this is the case if you're going to launch Rancher and Kubernetes on nodes which are hosted in an infrastructure provider such as Amazon EC2 or DO, DigitalOcean, Azure, vSphere, etc. For that, we need port 22 always open. Another port that we need always is port 443 or for SSL communication. Then if you're using hosted Kubernetes providers, for example, the AKS, EKS, GKE, Rancher can talk and integrate with these APIs. These providers will basically set up your Kubernetes clusters, and Rancher will try to manage this cluster from outside using these APIs. So for that, Rancher needs the port 6443 open for at which the Kubernetes APIs for these clusters are available. Rancher can also be launched, used to launch Kubernetes cluster using your custom nodes or bare metal server. Now here you have some inbound roles which we have documented for various ports we need that we just went over. For your help, you can check the documentation for details. Next is the server tags. Now Rancher server is distributed as a Docker image. So we are using Docker Hub to store our images. So when you install Rancher, you are basically installing the Rancher latest image. And it is the development release. If you want a newest stable release, which is recommended for production, you should use the tag stable. Now, the single node installation is what we will go over. You can follow along if you have a node ready. So first is you have to provision a Linux host with necessary hardware and software requirements that we went over. Rancher 2.0 uses SSL for security purposes. SSL secures all the Rancher network communication. Like when you log in or interact with a cluster, it's all secure. There are various options of setting up SSL. You can, when you are launching the Rancher server, you can provide default self-signed certificate, which is the easiest way to get started with Rancher. There are other options like you can bring your own certificate. You can bring your own certificate which is signed up and recognized by a certificate authority or a private CA root certificate. And you can always use Let's Encrypt, which is a cool tool to get CA signed certificates quickly and get you started. So for the demo purposes, we will be using a default self-signed certificate method. Once you have your Linux host, you can log in and then run this command on your host to launch the Rancher container. So I have this DO host that I have already provisioned, and I have installed Docker on this host. So I'll just copy paste this command and it will pull the Rancher latest image from Docker Hub and try to install Rancher container. While it's doing the installation, it should be pretty quick though. I will also show I already have another Rancher set up here on a similar DO host. And once our installation is done, if you reach the node IP address /login, here is where you can reach the Rancher server platform or the UI that you have just launched on your host. So the installation is done. So let me quickly check if my Rancher setup is up on this. Now I'm using a self-signed certificate. That's why it is going to give me this error. You can always accept this exception and proceed, which will bring you to this page. Now, after your Rancher server is up and running, it will ask you to do some setup. So first thing to do is you have to set a specific password to use for your admin. You can also use a randomly generated password. The next thing is you have to set a Rancher server URL. This is the URL that all your nodes in your Kubernetes clusters will need to be able to reach Rancher server. So if you're locally installing Rancher, it's not a good idea to use localhost here if your clusters are not going to be able to communicate to localhost. So use an external IP address which is reachable by your clusters. After that, it takes you to this landing page. As you can see here, you have the global view, and we are into the clusters page where right now we don't have any Kubernetes clusters set up. So you can always click on add cluster and start adding a Kubernetes cluster. We will do that in a short while. Before that, I'll go over another feature of configuring your Rancher setup, that is authentication. So as you can see here, I just set up the admin password. So it is showing me that I have logged in as the default admin, which is a local user. So right now, Rancher comes up with local authentication always on. If you go to the users, you can see that one user is present, which is the default admin in active state. But we can go over and see that we can have another authentication providers also set up along with the local auth. So Rancher provides a wide array of authentication provider support. You have Active Directory, you have the Azure AD, GitHub. We also support SAML protocol where you have the ping, shibboleth, and free other flavors of SAML. Free IPA is another flavor of LDAP. Microsoft ADFS is also there. And of course, the open source Open LDAP provider can also be used. So each of these providers will ask for a bunch of configuration parameters to integrate with your auth provider, which is running in your enterprise. And you can configure these providers and Rancher will pull in the necessary information about the users or groups you are going to set up in your Rancher setup from this provider. We can quickly go over how to set up a GitHub application. Now, for that, what you need is basically the URL at which your Rancher server is running. So you can go to your GitHub page and provide access to this Rancher setup, provide its URL and the callback URL that GitHub will be using, and can register your application there. What it gives you is a two parameters, client ID and client secret. So you can put them in your Rancher setup and set up GitHub authentication on your Rancher cluster. It will go and ask GitHub to authorize this user. We just did that setup, and so Rancher gets the access and gets set up with GitHub. This is another configuration feature of authentication providers. What Rancher asks you is what access you want to configure and who should be allowed to log in and use Rancher. So site access has three options. You can allow any valid users in your auth provider. So any valid GitHub user will be able to log into your setup. Or you can restrict it to allow only members of clusters, projects that you create, or any other authorized users and organizations. So here you can search for any users that you want to give access to, and GitHub, what Rancher will do is call GitHub APIs to search these users for you, and you can go and add them and give them access to your Rancher setup. Also, you can restrict access to only a set of users or a list of users and organizations that you can search for from this Dropbox. I'll give the Rancher organization the access and say save. Now my setup is done. A Rancher server container is running and we have GitHub auth also set up. We can go back to our global view and start with adding some Kubernetes clusters. Now, if you go to add cluster, it provides a lot of options. You can see that there are three categories quickly. You can launch a cluster in a hosted Kubernetes provider, which is the GKE or EKS or Azure Kubernetes service. For launching the clusters in this providers, what you will need is service tokens or service accounts that these providers work with. So you can give some name to your clusters here, provide, for example, my GKE cluster. Under member roles, you can add members who have access to your cluster. This again shows you a drop box where you can start typing in, and Rancher will search for these names and on your auth provider that you have set up, and you can add them as member to your clusters. Along with adding them, as member to your clusters, you can also provide them roles that you want to assign to these users or groups. So you can say they should be cluster owner, or they should be member, they should be read-only users, or you can define custom roles as well. So here you can also define custom roles and assign permissions for the users for what operations they can do within your clusters. You can again provide say dev team as member of my cluster. Now, the next will be the service account that you will have to provide. Now, I'm going to use the Google Container Engine service account that I already have created. And then it brings us to the nodes. What are your node requirements? I can keep it to say 3 nodes or the default and say create. Now what Rancher 2.0 is going to do is talk to the GKE cloud provider, Kubernetes provider, and provision your nodes on the cloud provider and set up your cluster. Now while this is getting set up, we'll go over to another Rancher setup that I already have and look at other ways of adding clusters. So in here, I already have a cluster provision and it's a DigitalOcean cluster. So I'll go back to my add cluster view. We just looked at how to create a cluster using a Kubernetes provider. Other way to do that is from nodes in an infrastructure provider like EC2 or Azure or DigitalOcean or vSphere. So while doing that, you can just choose the infrastructure provider when you want to go and provision your nodes. Provide name again to your DO cluster. Once again, you can add members, you can assign them roles or create new roles inside them. You can also add groups as members. And there are various cluster options that are available. Now in here, we provide with you what are the Kubernetes versions that you can use to set up your cluster. Then we have 3 different network providers that are available via Rancher platform that you can use. Canal is the default. Then here you have project network isolation, which is disabled by default. But with Canal network provider, you can enable it. Project is a Rancher concept which we can go over in detail later. But what this is going to provide is within projects, which is again a type of grouping, this feature will help you set up isolation between the projects so that applications that you're launching within projects cannot talk to each other and they are isolated. You also have pod security policy, which is a Kubernetes concept. We support that, which is disabled by default. You can enable your metric server monitoring. You can ask Rancher to have in Nginx ingress controller or ingress support by default. It's enabled by default, but you can disable and have your own ingress controller also launched on your cluster, which listens to your ingresses. Further, you should use a supported version of Docker, but if you are going to use an unsupported version, you can ask Rancher, you can tell Rancher that you are going to do that. Then there is an option of cloud provider. Configuring a cloud provider in a cluster will need you to have all the other prerequisites already taken care of. When you're telling which cloud provider you are going to use, then Rancher will use accordingly those features available in the cloud provider. I'm going to go with the default cluster options, and we are trying to set up a cluster by having nodes in an infrastructure provider. For that, there is a concept called as node template. So in here, under your user, you can always create templates of nodes for your choice of infrastructure provider. User access token and keep this template ready as to what should be your CPU, memory, and other requirements for the nodes. And then when you are adding a cluster using that provider, you can choose the already pre-created node template and which Rancher will use to go and provision the nodes on the provider. Here you can see we have 3 roads that you can choose for your nodes. So these are HCD, which is a DB role or where the database resides. Control plane, where is the management, Rancher management control layer is going to operate on, and then the worker nodes on which your workloads that you deploy in your cluster will get scheduled. So HCD and control plane cannot be used to schedule your workloads. You need a worker node in your cluster to deploy applications. Now I have a DigitalOcean cluster already created here with 2 nodes. Another way of creating a cluster is you can always bring your own existing nodes, is custom. So here you can give name. Once again, you can choose members of your cluster, assign them roles. You can go over the cluster options that we just went over and tell Rancher how you want to set up your cluster. One thing I will again mention is that all of these options can also be provided to Rancher in a YAML format. So you can prepare a YAML file and provide Rancher with these cluster options in a YAML format. And you can read that file by using this option in the UI. So next, after you choose that, what Rancher gives you is what should be the role of your node that you are provisioning for your cluster. So I'll use a single node right now with all the 3 roles. And here you can provide what is the IP address of your nodes that you already have that Rancher should talk to and set up your Kubernetes cluster. So to demo that, I already have a node provisioned on DO that we can use to provision the custom cluster. Next is Rancher gives you a Docker run command that you should be running on your node to get your Kubernetes cluster set up. When you say done, your cluster object gets created, but it shows you that it's still in the provisioning state because it's waiting for all the nodes to register. You just created the cluster, but we have not yet actually gone to a node and installed various components that Rancher needs to talk to that node. So let's go to that cluster and go to that node. Oops. So I just SSH here. Okay. Let's try. Yeah, should probably go back where my keys are. Here you go. So I have Docker already installed on this node. Go back to get my Rancher provided Docker run command. You can always edit here and make sure that your IP address is there. Choose the roles and copy this. Go back to your node and run this command. This will install all the necessary Rancher agent containers that are required for Rancher to communicate with the cluster that is setting up on this node. And in here you can see all the status updates of this cluster provisioning, where Rancher is registering the node, one node is registered, and starting various health check and other components on this node. So while this is provisioning, let's see our GKE cluster here that we provisioned on the GKE provider is already set up and ready for use with 3 nodes. Now, while our custom cluster is provisioning, go back to add cluster and talk about another way of having your cluster set up with Rancher. The last, Rancher provides the cool feature of importing an existing Kubernetes cluster. So if you already have a Kubernetes cluster running somewhere, you can always ask Rancher to sync up with this cluster and start managing that cluster externally. So you can provide an name to this cluster. Again, you can provide member roles and add members to your cluster and create. What it gives you is 3 commands, options of 3 commands. This is basically the same thing that you have to run depending on how your cluster is set up. So if you're using self-signed certs, then this is the 3rd command that you want to use to avoid any certificates signed by unknown authority errors. So what you have to do is you have to copy the command and run it on your existing Kubernetes cluster to ensure access to your cluster. So here you can see that our custom cluster that we just set up on one of our nodes is ready and provisioned with 1 node, which is having all the roles. Going back for import cluster, let's see if we can import an RKE cluster that I have created. So RKE is again Rancher provided Kubernetes installer, and it helps you to get a Kubernetes cluster get started. So here my RKE config or my cluster YAML is already there. My kube is provided. If I do a kubectl, and it can show me what are the nodes present in my cluster. And then here, if I run this command and provide my kube config, yeah, so the file name is wrong. What it will start doing, Rancher will get access to your cluster. It will create some components that are needed to run Rancher in your cluster or give access to your cluster. So here are a few namespaces that it creates is the cattle system namespace. And in this namespace, all the Rancher 2.2 components and microservices are launched in order to manage your cluster. It creates some service accounts to talk to your Kubernetes cluster. The necessary role bindings and secrets are created. Now, if you use this importing cluster and use Rancher to manage your already existing cluster, but then you want to go back, and then you can always delete this cattle system namespace. And what it will do is take out all the Rancher components from your cluster, and Rancher will no longer have access to your cluster. Rancher definitely adds some annotations in your Kubernetes cluster, but they will just stay there as metadata. So you can import your cluster as well as you can take out access, Rancher's access to your cluster very easily. So here we have the imported cluster already pulled in to Rancher server and showing it in the nice UI. So we just went over all ways of adding cluster setup. We had a node in DO, then we had custom cluster setup, and we also imported an existing RKE cluster that I had set up. With this, I'll pause for any questions, Matthew.
Yeah, thanks, Prachi, for going through all that. So there are a few questions. Let's see. Mathine asks, can I run Rancher on Mac just to get my hands wet, get started?
Yes, you can. I'm running Rancher on my Mac development setup.
Cool. Anything special that it needs to know?
You have to just make sure your Docker version, supported version is available. If you're using your Mac local setup, you have to make sure that the Rancher server URL that you're going to use for your Kubernetes cluster is accessible from outside. So for that, what I do is use ngrok, which redirects to my localhost URL where Rancher is running. And I use that ngrok command or the URL that it provides and sets it as my server URL. So what I'm talking about is this server URL under settings. You can always find it here. This server URL that Rancher will ask you to set up. And instead of the localhost, make sure it is a URL that is accessible from outside.
Awesome. Cool. Thank you. Okay, the next few are from Marunal, who asks, how do you monitor Rancher itself, and how well integrated is it with other monitoring tools?
You will have to set up Rancher itself loads its containers onto the Kubernetes cluster. So you will have to probably set up some monitoring tool to monitor that. I'm not sure how to give you a specific answer on that. So maybe you can go to our Rancher user Slack and post the question there. I'm sure you will get the required answer.
Great, cool. The next one is, does Rancher integrate with Splunk? What is the best way to get all of the logging into a single place, and how difficult is that?
So if I go down to a cluster view, so I'll in a short while I'll get to that. If you can hold on for a while, I'll come to that answer.
Okay, cool. Awesome. And then the next one is, does Rancher support CentOS?
Here are the node requirements that we have posted. So we have Ubuntu, Red Hat, and Rancher OS also supported. So it's not listed in here, but you can give it a try as well.
Okay.
I'm not sure. Yeah.
Cool. And if Marinol, if you're have more questions about CentOS, I think you can ask on Slack. And a couple other people have asked that at previous trainings too, and found some help on Slack. Okay, the next one is from Nathan, who says, this is kind of a complicated question, but I'll try to make it quick. If the physical node that a single node Rancher server is running on dies, can I start a new Rancher server Docker container and restore from backup on a node with a different IP address?
Yes, you can do that. So all the data is in etcd, which is in your Kubernetes. And so if you have backed up Kubernetes, you can always use that DB backup and spin up a new Rancher server and use volumes from and use that backed up data and have your clusters again running within Rancher.
Awesome. Okay, cool. There's a second part to the question, which you might have actually just negated, but he says, or does the IP address associated with the Rancher server URL need to be the same for it to be able to control the Kubernetes cluster nodes?
I don't get what they mean by needs to be the same, but the server, the IP address, if you're talking about, then when you are using the Rancher server on a different node, then yeah, you can go to the settings and you can update the server URL, and that will update the required setting. If this doesn't work, please feel free to come to the user Slack and post your question again.
Okay, cool. And then the last one is from Mohammed, who asks, is Rancher 2.0 available in the AWS marketplace?
Actually, I'm not very sure about that, so I'll probably direct you again to the user Slack or documentation to get this answered.
All right, cool. Sweet. That's it for now.
All right, so I'll just move on and quickly demonstrate some cool features that are available in this UI. Here you have the global view and which let me add various clusters. Next we have the cluster view. So whenever you add a cluster, you go down to that cluster, and here you can see that it shows the cluster's resource usage or health checks or what are the nodes available and a little summary about your cluster. Along with this, it has a cool tool available which says launch kubectl, which takes you directly to a shell window where you can run kubectl commands and talk to your cluster. Right now there's nothing there, but this is talking to my cluster, the demo cluster that I set up directly. Now, if you don't want to launch kubectl from within Rancher, you can always download the kubeconfig file of your cluster and use this for your kubectl client running externally. This is going to have some tokens which authenticate against Rancher first, and Rancher will redirect your commands to your cluster. Now, within cluster, you can always see the nodes that you have set up, what roles they are in, the version they are running, and the CPU and RAM available. Now, this is a custom cluster where the node was already set up and Rancher just set up the cluster. But if you go to a DigitalOcean cluster where Rancher actually provisioned the nodes on DigitalOcean, for that cluster under nodes, you will always get an option to add more nodes to your cluster. So you can just scale up the nodes from here or scale down, and it tells Rancher to go back to your DigitalOcean or any provider you're using and provision your extra nodes. Next, within the cluster view is storage. So this is storage in Kubernetes is a bit hard and confusing. So Rancher provides these two features under storage where you can add persistent volumes, choose the volume plugin based on the infrastructure you're using, and then use these volumes and storage classes in your applications running on your cluster. Next is we come to projects and namespaces. Now, namespaces is a Kubernetes concept. All the resources that you create on your Kubernetes cluster, they get associated to a namespace. Kubernetes cluster will always have the default namespace that is present. So you'll always see the default namespace. And now Rancher has introduced a new concept called projects on top of namespaces. So projects helps you group namespaces together. So it's a one-to-many relationship. Where this comes in handy is if you assign namespaces to say 3 developers in your team, but you have various configuration secrets or certificates that should be used, all of them should be using, then you don't have to create 3 copies of that in each individual namespace. What you can do is create a project by doing an add project here and then assign members to it and assign the namespaces to it that you want to add to that project, and then whatever common resources you want for those project, you can store it at the project level and they will be available in all the namespaces. Now you would always see a project default and a project system that is launched when you create a cluster with Rancher. Default is which contains the default Kubernetes namespace, and system is what we create to hold all the system related processes namespaces that are there. So the cattle system that we talked about, also the nginx ingress namespace that we create to launch nginx ingress controller. Now you can always move namespaces within projects. So if you want to move default to some other new project that you created, you can always do that using the UI. Members, we talked about how you can add new users from your provider or groups and give them roles. Next, I come to the tools that are available to monitor and logging in your cluster. So going back to the question that somebody asked about Splunk. So we have some login tools here and we integrate with all these logging tools like Elasticsearch, Splunk, Kafka. So yes, we do have integration with Splunk available. Then we also have a way to set up alerts for your cluster. Rancher already has some alerts set up by default. For example, if your node member usage is going over 70%, there is an alert already present. And you can always go and create your new alerts for if you want to monitor a particular system service or you want to monitor a particular resource or a node, you can create them. And when those alerts are triggered, you can ask Rancher to notify you using notifier. So in here under tools, you also have notifiers, which where you can add and we integrate with Slack, email, PagerDuty, webhook, and but whichever you set up, whenever your alerts are triggered, you will get the alert notified on this media. So this is quickly about the tools. Now I'll go back to the global view and we can talk about catalogs. Here, catalogs is nothing but a repository of Helm, Kubernetes Helm charts. So Rancher comes up with a catalog called as library, which is our official repository of curated application templates, which are maintained by Rancher. You can always enable the Kubernetes standard Helm repository, Helm chart repository, which is like the Docker Hub. And you can always also add your own catalog. If you have created some Helm charts, you can host them on GitHub, a Git-based catalog URL, and add a custom catalog. And Rancher will pull those Helm charts and show you within your cluster for easy launching the applications. So under cluster, if you go down to the project view, here are your workloads where you can start deploying your applications. And there's a catalog apps tab where you can say launch and it will show you a predefined set of Helm charts. Right is the Rancher's catalog. Choose whichever application you want, configure them and launch them directly here. Rancher will ask you the necessary configuration parameters that you need to answer in order to deploy this application, and you can launch them. I have already done this and launched, I think, in my DO cluster. And those catalog apps that get launched, you can always see under the workloads and catalog apps. Now, going back to global view, under security, you have the roles that you can define for setting up RBAC, and you have some pod security policies that you can go and customize or edit. It will let you define what kind of pods the users can deploy for your security. And the lastly, one thing that I want to talk about are the other ways of interacting with Rancher and your cluster. So kubectl is the Kubernetes client that you can always use, and you can use the kubeconfig that is provided for your cluster, and you can use kubectl to talk to your cluster. Other way is you can download Rancher's. So Rancher CLI tool you can set up on your external client, and what it offers is various commands to interact with Rancher itself, pull the various clusters, catalogs, projects, also Kubernetes resources like nodes, namespaces, and it also gives you, it doesn't come in between you and Kubernetes, so you can always use Rancher CLI to run Kubernetes kubectl commands using this CLI option. So you can always run kubectl commands like this using the Rancher tool. Quickly, before being able to use the Rancher CLI, what you need to do is log in against your Rancher server. So to do that, you have to set up keys for your Rancher tool. So you add an API key or a token here, and you provide that in your Rancher CLI login command, and provide the URL of your Rancher setup that you want to run against. And this way, the CLI will be able to talk to your Rancher server. get authenticated, and also run any commands and pull resources that you want to see. So I'll pause again for any questions, and I think I have covered most of the things that about 2.0 platform. So Matthew, are there any more questions we can take?
Yeah, let's see. Thanks. Okay, so Moonral asks if you could talk a little bit about how to upgrade from Rancher 1.6 to 2.0. Huge topic, but if you could mention it.
Yeah, so Rancher 1.6 used cattle and orchestration platform to launch your applications and services within your stacks on Docker. And cattle is a very different orchestration technology as compared to Kubernetes. Kubernetes, as we have seen, is a huge project with a lot of new specifications for resources, and it doesn't use Docker Compose that Cattle uses or Rancher 1.6 works with. It works with Kubernetes YAML. For example, if I go down to my cluster and my default project and my workloads, I already have 2 workloads running here. You can always see the YAML, Kubernetes YAML format for these workloads, and you can use them to launch the same workload on some other Kubernetes cluster. So as you can see, in Rancher 1.6, if you are a cattle user, 1.6 user, you know that you can see the configuration of your stack and services in Docker Compose YAML format or Rancher Compose format. But here, this Kubernetes YAML is completely different, quite verbose and complicated. And because of this difference in technologies, there is no direct upgrade path between these 2 versions available. So what I can tell you is I'll direct you to a series of blogs on our Rancher docs, and this blog series is aiming at helping you migrate various features that you are familiar with 1.6 and how you can get their equivalent features on Rancher 2.0. So you can follow these blogs, which are prefixed as from cattle KTS for various aspects that you're looking for. I hope that answered the question.
Yeah, great. Let's see. The next one from Alex. Could you talk a little bit more about how to deal with persistent volumes and storage classes?
So for that, for storage options within your cluster, Rancher UI as a provides ways to create persistent volumes where you can add your persistent volume on the infrastructure that you're running on. So you have to, if you're using EC2, you have to choose Amazon EBS disk and various parameters of your volumes, customize using advanced option if you need, and you can create these volumes as well as storage classes and refer them in your workloads that you deploy or pods. Now, I myself have not worked a lot on storage, so I cannot go into more details about this. So I'll ask you to please put your question on our users Slack, and I'm sure the engineers there, which have worked on this area, will answer your questions.
Cool. And actually, the next question you might have just answered, but Vladimir says, could you demonstrate the configuration of the AWS EC2 cluster so that persistent volumes, AWS EBS, would work?
So for that, if you go down to add cluster, so for that, you will have to use Amazon EC2, I guess, for your infrastructure provider and use your AWS access keys for making Rancher able to provision your nodes. But again, I myself have not worked with storage options. So I'm sorry, I'm not able to demonstrate that to you at the moment.
Oh, no problem. And actually, the next one is related too. It's from Alex, who says, how can I add AWS EBS volumes to a DigitalOcean cluster?
Again, sorry, I think that will be very difficult to do because Your volume will be running on EC2 Amazon infrastructure, and the plugin will not be able to integrate it with your DO cluster. But please do post all these questions, all good questions about storage on our Slack.
Cool. And I will mention that, in September we have an online meetup on, I believe, September 18th that is uh, purely on persistent storage, block storage. And so, that'll be 2.5 hours just on storage. So if you're not signed up for that, you can do that from the homepage of our website. Next one is from Marunal, who says, can you talk about CI/CD with Rancher or give a intro to it?
I myself, again, sorry, have not worked with 2.0 CI/CD a lot. So I think I'll again direct you to the Slack or our documentation to get some help on that.
Cool. Yeah, and again, that one actually we did just do an online meetup about at the beginning of August too, and that is the recording of that video is on our homepage. There's a link right near the top, so you can also watch that for free, and that has a ton of information. Okay, let's see. I think that is actually all of the questions. Let me just go through really quick and double check. Yeah, those are all the ones that we're able to get to. So is there anything else you wanted to say before we wrap up?
I think that's about it. That's what I wanted to go over. I hope I demonstrated various ways of setting up your Kubernetes clusters and get an integrated central portal to manage various clusters in one place. One thing I wanted to note that if you're coming from Rancher 1.6 background, where you have environments added, kettle environments added, and hosts available, the difference here is that you have multiple clusters available. So you have cluster plus a project equivalent to your kettle environment. So all your hosts are present within a cluster, and cluster plus the project that you create is equivalent to a kettle environment. That's about it, Matthew. I hope I answered a bunch of questions and the demo was useful.
Awesome. Cool, very cool. Well, let me take back control of the presentation to just wrap up with two more slides. And this, as we've mentioned a number of times, slack.rancher.io is our Slack. So please, follow up there. And again, this whole session has been recorded, so you'll get the recording of the video as well as the slides and the questions that were asked. And that is it. You can tweet about this on Rancher K8 or join next week's training because we do this every week. And like I said, there is a persistent storage meetup that will happen September 18th too, so that everybody can join. That'll really dive into block storage and persistent storage. So that's it. Thanks again, Prachi, for your time, and thanks everybody for your questions and participation. Have a great rest of your week.
Thank you, everyone.